Okay, so let's talk about double replacement reactions and just kind of go over some rules of them, and then we're going to do some examples of them, okay? So the golden rule of double replacement reactions, only the double replacement is if it, to actually happen, two aqueous reactants must produce at least one new phase of matter, either solid, liquid, or gas. If both products are aqueous, which means they just dissolve in the water, then there's no reaction that happens. Everything just becomes these spectator ions, okay? So again, on the double replacement reactions, we have the cations, or the anions in this case, but either the cations or anions switching, cation and anion, and that's kind of the overall equation for it, okay? So what happens if we make a solid, or how do we make a solid from this, or a precipitate occurs? All right, this is when two of your liquids come together and a solid comes out of it. How do we get it? Well, a compound and a compound, you get a solid and a compound. Now, here are the rules, and you're going to kind of want to make a note of these. You can take a picture of it. You can do whatever you need to, but make sure you know these, okay? All right. Always soluble are anything in group 1 except hydrogen. Ammonium, nitrates, and acetates are always soluble no matter what they're mixed with. Most of the time soluble are your halides. However, when you pair them with heavy metals like silver, lead, and mercury, they then become a solid, okay? And then mostly soluble are the sulfates, again, unless they come in contact with a heavy, silver, lead, calcium, strontium, or barium, and those are in 2A, all right, or in group 2. And then almost always insoluble are going to be your carbonates, your phosphates, your sulfides, and your hydroxides. And the only time they are not insoluble or become soluble is if they are paired with things. These override everything. So the group 1 ions will make it so everything's soluble. Okay? So with that said, let's get some examples here. And what we want to do is we want to learn how to do the overall equation, the complete net ionic equation, and the complete ionic equation and the net ionic equation. So we're going to do all of them. So for the reaction between aqueous silver nitrate, so silver nitrate is HAgNO3, and we're going to put that AQ there, plus potassium chloride, and we're going to put that AQ there. Now, the double replacement reaction is that potassium is going to flip over to nitrate, and the silver will flip over to chlorine. So we're going to do the AKNO3 aqueous. And here's that example of Ag. Remember, silver with the halides is now going to become a solid. So AgCl, and that's going to be the solid. Okay, so that's the overall equation for it. And in this case, everything is balanced. There's one of each of everything over there. So everything's good. The complete ionic equation is going to be Ag plus 1, and that's aqueous, plus NO3. That's going to be aqueous, plus potassium, which is going to be aqueous, and chlorine, which is also going to be aqueous. And then what happens is we've got the potassium continues to be aqueous. The nitrate also continues to be aqueous. And then we have the AgCl is going to be the solid. And this would be the complete overall, complete net ionic, or complete ionic reaction. Notice here, on this side, I have K plus and NO3. So these are what are called spectator ions. They are just sitting there, and they're going to continue to be aqueous. So in order to write my net ionic equation, I'm going to write Ag plus 1 aqueous plus Cl minus aqueous, and I'm going to get AgCl solid. And this would be the net ionic equation right here, okay? So we've got the overall equation, the complete ionic equation, and the net ionic equation right here, all right? So that's the first one. The second one, aqueous solutions of barium nitrate. So barium nitrate is 2. That's barium nitrate. And this is going to be aqueous. And sodium sulfate is going to be Na2SO4, aqueous. And we're going to get, again, we're going to switch them, and we're going to go NaNO3 plus Ba. This is going to be aqueous as well. And BaSO4, which is now going to be a solid because sulfates are usually soluble unless they are with barium. So barium right here makes it so this is going to become a solid, and these are going to stay aqueous. So now we're going to do the complete ionic equation, which is Ba plus 2 aqueous plus 2 NO3 minus aqueous plus Na2 Na plus. Let me see, we got that. That's going to balance that equation. 2 Na plus aqueous plus SO4 minus 2 aqueous. And then from that, I'm going to get 2 Na plus aqueous plus 2 NO3 minus aqueous. And from this, I'm going to get the BaSO4 solid, because the barium and the sulfate, if you know these rules, this is pretty easy. Now that's the complete ionic equation. From this, then notice on this side, I have the 2 Na pluses and the 2 Na pluses. That's the spectator ions. And I've got the 2 NO3s and the 2 NO3s. Those are spectator ions. So what I do from this is I'm going to now make the net ionic equation and make it Ba plus 2 aqueous plus SO4 minus 2 aqueous. And I'm going to get BaSO4 solid. And that's kind of how the solids work. Just know these rules right here at the top. Know these rules. And if you know these rules pretty well, sometimes you're given and sometimes you're not. Just know these rules right here, and you can tell which ones are going to be based on the equations. Okay, I won't do the third one. We are going to move on to now, that's making solids. The next thing we're going to do is we're going to move on to making liquids. Okay, so we're going to move on to making liquids. And what we do in the liquids is we're going to do a strong acid base neutralization. All right, they cancel each other out to create pure liquid water and a leftover dissolved salt. The two cations are going to, or the cation and the anion are just going to dissolve in the water. All right, so you've got an aqueous acid plus an aqueous base. We're going to end up with water and the salt. Look for hydrogen at the front of the acid and hydroxide at the end of the base. That's important. And know these strong acids right here, because the strong acids are going to be the ones that do this. All right, is Cl4. This should be Cl4 minus. And this is HCl3 minus. Okay, no, it's not minus. HCl4 and HClO3. Okay, all right, so write the equations for this. Nitric acid with potassium hydroxide. Nitric acid is going to be HNO3, and this aqueous plus potassium hydroxide, KOH, aqueous. And in this case, what we're going to get is, it is a double replacement reaction, which is going to give me KNO3, and that's aqueous plus H2O, and that's going to be my liquid that's created. Okay, so that's the liquid. And it is double replacement because the K and the H are going over. Notice it becomes HOH, which is H2O. So this is the overall reaction right here. It is all balanced and ready to go. So now we're going to do the complete ionic reaction, which is H plus aqueous plus NO3 minus aqueous plus K plus aqueous plus OH negative aqueous. That's just breaking everything into its ions, and your cation, your anion, your cation, your anion, all into its ions. And then what we're going to do is what shakes out from that. And what shakes out from it is K plus aqueous plus NO3 minus aqueous plus H2O liquid. Do not separate that, okay? Because that now becomes its own separate thing. So it becomes the liquid, all right? Notice here, this is the complete ionic equation. From this complete ionic equation, I notice I have K plus on both sides, and I have NO3 on both sides. So I cancel those out. Those are what are called spectator ions. And then what I'm going to get from this in the net ionic equation is H plus aqueous plus OH negative aqueous. And from that, I'm going to get H2O liquid. And that is your net ionic equation and is what actually happens. This is everything that's going on. This is the actual reaction here. Okay, let's do a second one. And the second one is write equations for the reaction when you mix aqueous hydrochloric acid, so HCl aqueous, plus sodium hydroxide, which is NaOH aqueous. And I'm going to get from that, again, double replacement, the NaCl and the HOH. So I'm going to get NaCl aqueous on this plus H2O, and that's going to be my liquid. All right, that is created from this. All right, so this is the overall reaction. Notice it's one of everything, so everything matches, everything's good. So now I'm going to do my complete ionic reaction, which is H plus aqueous plus Cl minus aqueous plus Na plus aqueous plus OH negative aqueous. And I'm going to get from that Na plus aqueous plus Cl minus aqueous, and I'm going to get H2O liquid. Again, this is what's going to happen from this. All right, now notice on this one, I have the Na plus as an ion, Na plus is an ion, Cl minus is an ion, Cl minus is an ion. And from this, those are my spectator ions. The actual reaction or the net reaction is H plus AQ plus Cl minus, plus OH minus AQ yields H2O liquid, okay? So that same thing is going to happen. The basic overall equation from this is you're going to have H plus OH negative gives you water. And that is the net ionic equation for those, okay? And then the last one we won't do the last one. So the last one we're going to do is when I get gas out of it, okay? So the third kind of reaction for double replacement would be the gas maker, or I'm going to get gas out of it. And what happens here is you're going to look at the product of the reaction, okay? So how to spot it? You predict a product that is highly unstable, so you cross it out and rewrite it as water and gas. So if you notice this one, what is the net ionic reaction when aqueous potassium carbonate reacts with hydrobromic acid? And the trapdoors or unstable intermediates are carbonic acid, sulfurous acid, and ammonium hydroxide. So in this one, we're going to write our equation, which is potassium carbonate, K2CO3, plus hydrobromic HBr, and that is all aqueous. Everything's aqueous. Sorry, my AQs are a little weak, but aqueous. From this, I would typically get KBr, aqueous, plus H2CO3. But this immediately decomposes into H2O plus CO2. Okay, so you're looking at your products as one of these three things. If you see your product is H2CO3 or H2SO3 or NH4OH or ammonium hydroxide, then you're going to break those down into something else, and this is the something else they're going to break down into. Okay, all right, so we have that, and make sure that these are K2. So I've got that, and I've got that's going to balance that equation for me. Now, if I'm going to write the complete ionic reaction, I'm going to get K2K plus aqueous plus CO3 minus 2 aqueous plus 2H plus aqueous plus 2Br minus aqueous. And that's how they're all going to go into. Now, what I'm going to get from that is 2K plus aqueous plus 2Br minus aqueous plus CO2 plus H2O. As soon as you see that carbonic acid, you immediately change it, immediately disintegrates. And what you're going to get from that is that carbon dioxide gas. That's the bubbling of that gas that comes out of it, okay? All right, so that's what that one is. And then the net ionic equation, notice I have K plus, I have Br minus, So my overall equation is 2H plus aqueous plus CO3 minus 2 aqueous, and that's going to give me H2O liquid plus CO2 gas. And that's what's going to come from this one, okay? All right, so that one is the first one that creates the gas. And remember, look for these three gases right here. The last one is going to be the overall reaction for produces a phthalate sodium sulfide. Sodium sulfide is Na2S plus hydrochloric acid, which is HCl. And both of those are aqueous. So we're going to keep writing aqueous. And then what we're going to get from this is we're going to get NaCl, which is the salt, plus H2S, which is now my sulfurous. Yeah, H2S, which is going to come from this. And this is going to be a foul smelling. I know that this doesn't say it up here, but this is the other one you're going to get, okay? So H2S. And so this is going to be a gas from this. So from this, what I'm going to get is aqueous and that gas right there. All right, so this becomes Na plus, two of them, aqueous, plus S minus 2 aqueous, plus two of those. 2H plus aqueous plus 2Cl minus aqueous. Notice when I'm writing these balanced equations, I take all that stuff down and I'm just keeping track of what are my ions that possibly could come from this. And what I find here is I'm going to get my 2Na plus aqueous plus my 2Cl minus aqueous, and I'm going to end up with this H2S gas. Okay, notice this stays together. The two ions go together. This is going to bubble up above it, and it's going to be a foul smelling. It's going to smell like rotten eggs. All right, so I've got this one right here, and notice here my spectator ions are Na plus and Na plus, and Cl minus and Cl minus. So what I end up with is 2H plus aqueous plus S minus 2 aqueous, and that's going to give me H2S gas, and that is my net ionic equation for this one, okay? All right, let's look at our last one. It says if you mix sodium chloride, which is NaCl aqueous, plus KNO3, which is potassium nitrate, KNO3 aqueous, what you're going to get from this is, notice both of these, if you remember back to the beginning, both of those cations are always soluble. And the chlorine and the nitrate, sometimes they depend, but since these are both soluble, neither one of those are going to create anything with anything. So what they are going to just do is they're going to switch places with KCl plus, if I'm writing it, KCl and NaNO3 aqueous. But in reality, what's going to happen is I've got Na plus 1 aqueous. This is going to be the overall reaction, net reaction, complete ionic reaction, plus Cl minus aqueous, plus potassium aqueous, plus nitrate aqueous. And it's going to go to Na plus aqueous, plus Cl minus aqueous, plus K plus aqueous, plus NO3 minus aqueous. Now, if you notice, all of them just stay dissolved, so there's really no reaction that happens here. These are all spectator ions, and nothing happens in that reaction, okay? So those are the types of chemical reactions, double replacement chemical reactions that you have, and the outcome of each. I hope that helped.